how to smash probability with the normal model. In this video, we're going to do a quick review of how easy probability can be anytime you incorporate the normal distribution. This is going to help you get an amazing score on the AP test for sure, because so many questions deal with probability in the normal model. All right, so here's the deal. When a problem states that a quantitative variable follows a normal distribution, probability should be very easy, as long as you have a few simple tools. You need to understand the z-score formula. You need to be able to use normal CDF on your calculator or use your Z tables that you may use, but that's kind of old school. We like to use normal CDF. We can also use invert norm on our calculator. It's another tool that we need. And we need to have a basic understanding of how random variables can be combined. We can even incorporate conditional probabilities into the mix as well to make for some super fascinating problems, but they all start with the normal distribution. Let's dive into a basic problem here. The distribution of weights of a certain species of beetle follows a normal distribution. There's that keyword that's going to be very helpful, with a mean of 18 grams and a standard deviation of 2.5. Let B be the random variable for the weight of a random beetle of this species. So, if I find one of these random beetles laying around on the ground, I don't know how much it's going to weigh, but B represents a random variable for how much that beetle could weigh. But here's the best news. The weight of that beetle follows a normal distribution with the mean of 18 and a standard deviation 2.5. With that knowledge, probability questions are really easy. Here's a couple easy ones. So if a random beetle of this species is found, what is the probability it weighs at least 22 grams? First, let's make sure we know what at least 22 grams means. That is the probability that one of these beetles is greater than or equal to 22 grams. At least means more than. All right, here's how easy it is. First, we need a z-score for 22 grams because our calculator, or even if we use the normal tables, they only understand the language of z-scores. So I'm going to take 22, that's the value I'm talking about. I'm going to subtract the mean, I'm going to divide by the standard deviation, and I'm going to get my z-score. Listen, don't be afraid to grab a calculator and do the math. Just make sure you do the numerator first and get a 4, then divide by 2.5, and you get a z-score of 1.6. So essentially, I'm trying to find the probability that a z-score is less than 1.6, not less than, I'm so sorry, greater than 1.6. Now, does the or equal to sign matter? Honestly, with the normal model, no. It doesn't distinguish between greater than or equal to. Now, how am I going to do this? Well, you could use a z-table or you could use your calculator. We're just going to go and grab second vars to get to normal CDF. We want to start at 1.6 and look above it. So I'm going to use a lower value of 1.6 to an upper value of 99. 99 is basically acting as my infinity. A z-score of 99 is astronomically large. So we're just going really, really high. And we're going to calculate and get our probability 5.48%, 0.0548. 0.0548. So 5.48% of all beetles of this species are going to be at least 22 grams. How easy is that? All right, let's try another one here. If a random variable of this species, a random beetle of this species is found, what is the probability it weighs no more than 15 grams? All right, what does no more than 15 grams mean? That means that we're trying to find the probability that a beetle of this species is less than 15 grams. Technically less than or equal to, but remember the normal model doesn't differentiate between less than or equal to or just less than. But the point is, no more than 15 actually means less than 15. First thing we got to do is get a z-score so we can be in the same language because all normal distributions follow the common language of z-scores. Go ahead and grab a calculator. Make sure you do that numerator first to get a negative 3, then divide by the 2.5, and we get a z-score of negative 1.2. So essentially, we're asking to find the probability that a z-score is less than negative 1.2. And to do that, once again, second vars on my calculator, go and grab normal CDF. Because we're looking less than, we're actually going to start at negative 99. Negative 99 is, again, essentially acting like my negative infinity, really, really, really low. And we're going to go up to a value of negative 1.2. Just remember that normal CDF works lower to upper, left to right. So if you're looking more, you got to go above. If you're looking less, you got to go below. Just make sure you understand how that works. Go ahead and hit paste here, and we get our probability, 0.115. So about 11.5% chance that if we find one of these beetles, it's going to weigh no more than 15 grams. How easy is that? All you needed was the normal CDF on your calculator. All right, let's see if we can understand how to use invert norm. All right, this question says, what is the weight of a beetle that marks the top 10% of all beetles? So I'm trying to find a weight that marks the beginning of that top 10%. Now, I don't know what that weight is, but with invert norm, I actually can find the z-score. Essentially, what I need to do is start backwards. I need to figure out what z-score has 10% above it, which also means 90% below it. If I could figure out the z-score that has 10% above it, 90% below it, I could then use the z-score formula in reverse to find the actual weight of this beetle. So this is exactly what invert norm does. So second vars, go to invert norm command 3 here. Now the area it wants is the area to the left. Now I could do center or right, but I'm going to keep it as left. Now some people don't even have that option for left, center, right. That means you only have the option of left. So that's why I'm going to leave it left. So if I want to find the z-score that has the top 10%, that's a 10% area at the top, that means there's 90% below. So I'm going to type in 0.90. Now why am I typing in 0.90? Say it one more time. If I'm looking for the top 10%, that means there's 90% to the left. I actually could type in a 0.10 there, but I would need to select right. But again, some people's calculators don't even have that option for left, center, right. It's automatically set to the bottom or the left. So that's why I'm going with that option. All right, this is going to give me the z-score that represents this mark. So z-score of 1.282. This z-score of 1.282 is the z-score that marks where that top 10% or bottom 90% starts. So all I got to do is use my z-score formula in reverse. I know the mean, I know the standard deviation. What I don't know is my x value right here, but I do know my z-score for that marking, and that's why all I got to do now is work backwards. So I'm going to take my z-score of 1.282. I'm going to multiply it by the standard deviation of 2.5. Then I'm going to add the 18, and that is how I can find x. 1.282 times 2.5. Add 18 is a value of 21.205. So a beetle weighing 21.205 grams or more is going to be in that top 10%. All right, a beetle of this type is considered miniature if its weight is in the bottom 3%. So if you're in that bottom 3%, you are considered a miniature beetle. How much would a beetle have to weigh to be considered miniature? Well, once again, I need to figure out what z-score. If I can figure out the z-score for that bottom 3%, which would be equivalent to the top 97%, then I could work backwards using my z-score formula. So once again, this is a great time to use invert norm. And this time I want the left, the bottom, that is the bottom 3%. So I'm actually going to leave it as 0.03. And I'm going to leave it as left because it's exactly what we want to the left. That is the bottom. I could type in 0.97, but then I'd have to select right. But I'm always going to go with left. All right, so this is a z-score that represents that bottom 3%, negative 1.881. Negative 1.881 is the z-score. I don't know the weight. I'm about to solve for it, but I do know the mean, and I do know the standard deviation. So now all I got to do is take that z-score, multiply by the 2.5, add the 18, and I got my weight. Negative 1.881 times 2.5 plus 18 is a weight of 13.2975. You can round that if you want, grams. So any beetle that is weighing less than 13.2975 grams would be considered a miniature beetle. All right, now let's really step it up a notch. This is where we're going to actually incorporate conditional probability. What is the probability that a beetle of this species is miniature? Well, actually, if I stop right there, if I don't read the rest of the question, if I don't, look at this last part, like that last part wasn't even there, well, I'd be like 3%. Like literally the last question told me that the bottom 3% of all beetles are considered miniature, and I found the weight for that to be 13.2975. So again, if the question started right there, what is the probability that a beetle of this species is miniature? 3%. 3% of beetles are miniature. I already said that. But there's a given here which makes this conditional. It says given that it weighs no more than 15 grams. So they want me to find the probability that one of these beetles is miniature. Given, see that's why there's that line there, that's conditional probability, that it weighs no more than 15 grams. That would be a beetle less than 15 grams. Technically less than or equal to, but remember the normal model doesn't differentiate. So to understand this question, I have to understand conditional probability. Very quickly, the formula for the condition probability, the probability of A on the condition of B, is equal to the probability of A and B on top, all divided by the probability of the condition B. So I actually have to do two calculations. In the denominator, I have to find the probability of the condition, that the beetle weighs less than or equal to 15 grams. In the numerator, I have to find the probability of both. The beetle is miniature and less than 15. Oh, I guess I should put a less than sign there. All right, so, oh boy, let's see here. Okay, so first, let's do the denominator. The probability that a beetle weighs less than 15 grams. Now, to be honest, I already did that. That was one of the questions we did earlier. I'm just trying to save some time right now. But again, we found the z-score for 15. We used my normal CDF and looked below it, and I got 0.115. So I already know that the denominator here is going to be 0.115. That's the probability that a beetle weighs less than 15 grams. All right, that's easy. The numerator is both miniature and less than 15 grams. Miniature and less than 15 grams. Now, this is where it's a little bit tricky. We just got to think about this for a second. Miniature, we already determined right here, is less than 13.2975. Then we also have less than 15. Well, the only way you could be both miniature and under 15 is if you're miniature, under 13.2975 grams. And again, what's the probability that a beetle is miniature? We already know that that's 3%. So my numerator is 0.03. Now, let me explain that just a little bit more slowly again. The probability a beetle is miniature is 3%. Got it. Less than 15, well, that's less than 15. Miniature is 13 or less. So basically what I'm trying to say is if you're miniature, you're already less than 15 grams. So the probability of both of these happening would be the 3% because I got to be miniature under the 13 grams, which already makes me under 15. So what's the probability of that happening? 3%. So now all I got to do is divide and conquer. 0.03 divided by 0.115, and I'll get my answer, 0.261. So if I have a beetle and I already know that that beetle is less than 15, there is a 26% chance that that beetle is miniature. Why did it go up? Because if I'm less than 15, I'm already on the small side. So the probability of a miniature beetle being found amongst small beetles, guess what, is going to be more likely. Pretty easy. Hopefully that makes sense. All right, now we want to talk about combining random variables and incorporating probability. Often probability questions are asked that involve combining random variables together. Now, adding or subtracting means is very simple and straightforward, but combining standard deviations requires to remember a few rules. Rule number one, you actually can't combine standard deviations under no circumstances, but you can combine variance. Now, don't let this be too confusing because if you take standard deviation, square it, you have variance. It's really that easy. It's just standard deviation squared is variance. And you are allowed to combine variance. Now, the second rule is that variance always adds. So even if a problem is looking at the difference between two random variables, variance always adds. And then the last thing is once you have your total variance, we don't want variance, we want standard deviation. So once you have your total variance, how do you get back to standard deviation? Well, if standard deviation squared is variance, then the square root of variance is standard deviation. So once you have all of your variance combined, because you are allowed to combine variance, then you can take a square root of all of it to get back to your standard deviation. Now, it's easy for me to say that, but it's much simpler for you if I see an example. A grocery store sells oranges from two different distributors. Distributor X sells oranges whose weight follows a normal distribution. That's awesome. If it didn't say that, this problem would be impossible. Now, those oranges have a mean of 12 grams of standard deviation of 1.4. Distributor Y sells oranges whose weights also follow normal distribution, but they have a mean of 14 grams and a standard deviation of 2.1. What is the probability that the combined weight of an orange from distributor X and an orange from distributor Y is more than 32 grams? So we're trying to find the probability that the combined of an orange from X and an orange from Y is more than 32 grams. All right, to answer this question, we first have to think about the combined average, the combined mean. What is the mean of the combined X and Y orange supposed to be? Well, that's actually a really easy question. 12 plus 14 is 26. That's what the combined is supposed to be. On average, if I take two oranges, one from X and one from Y, put them together, the combined weight is supposed to be 26. But Oranges from X, oranges for Y both vary, so the standard deviation of this sum is also going to vary. But remember, I'm not allowed to just add 1.4 and 2.1. I have to add their variance. So the variance for the X is 1.4 squared. Again, all you have to do is put a square on it, and now you have variance. The variance for Y is 2.1 squared, and I am allowed to add those variances. Again, you're not allowed to add standard deviations, but you are allowed to add variances. I then need a giant square root around all of that variance to get me back to a standard deviation combined. So the mean was very easy and straightforward. 12 and 14 is 26. To find the standard deviation, a little bit tricky. Just have to understand those rules. So grab a calculator. Do not be afraid. Start off with that giant square root. 1.4 squared plus 2.1 squared is 2.524. 2.524. 2.524. Okay, now I'm ready to answer the question, what is the probability that the combined weight is more than 32 grams? That's what the question originally asked. So now I just got to figure out the z-score for 32 grams. Okay, subtract 26, because that's what it's supposed to be. That's the mean of the total, divided by the standard deviation, which I figured out was 2.524. So I'm going to grab my calculator, 32 minus 26. 6, do that first, divide by the 2.524, and I get a z-score of 2.377. So asking about the combined weight being greater than 32 is the same thing as asking about a z-score being greater than 2.377. How am I going to answer that? Well, you could use a normal table, or we could use our best friend, normal CDF here. So once again, we're doing greater than, so we want to start at 2.377. And, well, extra 7 there, sorry about that. And we want to go to 99. Again, that's simply acting as our infinity, a really unbelievably high z-score. All right, and we get a probability of 0.00873. 0.00873. So that's a very, very unlikely. So if this actually happened, that the combined weight of these two oranges from X and from Y was more than 32, I would be very shocked. I would find that to be very, very significant. In fact, that actually might lead me to believe that these means are incorrect. But again, that's a whole separate question for inference. But for right now, we're just asked to find the probability. All right, what about this very similar question? So same setup with distributor X and distributor Y, but this time we want to find the probability that a random orange from distributor X is greater than an orange from distributor Y. All right, we want to find the probability that an X is greater than Y. Okay, now an X is only supposed to be 12, a Y is supposed to be 14, so this doesn't sound very likely, but I guess it could happen. So to understand this question, we first have to understand the difference. What is the mean difference between X and Y? Well, that would be -2. That's simple math, right? 12 minus 14, that's a difference of -2. X is actually supposed to be 2 grams less. Okay, that makes sense. What about the standard deviation for X minus Y? Well, once again, we're not allowed to combine standard deviations. We're only allowed to combine variance. So the variance for X is 1.4 squared, the variance for Y is 2.1 squared, but even though this problem is working with subtraction, we're still going to add because of my second rule that I mentioned, variance always builds, it always adds. Then I need a giant square root to get back. Now remember, we actually already figured out this value because it's the same value that we saw earlier when we were adding. Because adding and subtracting does not make a difference when you're working with variance. So again, this is the number that we already got, 2.524. Now, how do I answer this question? Let's go back here for just a second. If I subtract the y over, I get x minus y greater than 0. So essentially, I'm trying to find the probability that the difference, x minus y, is greater than 0. If x minus y is greater than 0, that means x was bigger. Because if the x is bigger, then the y, when you do a bigger number minus a smaller number, you're going to get something that's positive, hence greater than 0. So to answer this question, I actually need to find the z-score for 0, because 0 is where the two oranges are tied. And I want to find the probability that I'm greater than 0, because if I'm greater than 0, I'm going to have my x right here be higher. And that's exactly what the question was asking. All right, so what's the z-score for 0? Well, I'm going to subtract the mean. What's it supposed to be? -2. Divide by the standard deviation, 2.524. Grab my calculator, 0 minus -2. Obviously didn't need to know that. I should have known that was 2. Divide that by 2.524. And I get a z-score of 0.792. So I need to find the probability that x minus y is greater than 0. So I found the z-score for 0, which is essentially trying to find the probability that a z-score is greater than 0.792. Now that's where I'm going to go to normal CDF on my calculator. I'm going to start at a z-score of 0.792, and I'm going greater than, so that's why I'm going to go to 99, acting as my infinity. And I get 0.214. So again, it's obviously more likely, that would be the opposite of this, the roughly 80-some%, or about 79%, but it's more likely that y is bigger because look at the data, y is supposed to be bigger. But, you know, everything deviates, everything varies. There is a chance that the x could be bigger, but it only has a probability of 21.4%, which again is likely, so I still think it could easily happen. All right, that's it for some basic probability when we're working with the normal model. Again, we only need a couple tools to help us here, primarily the z-score formula, normal CDF, and invert normal on our calculator, and a strong understanding of how they all work together. All right, hopefully this video will help you ace the AP exam.